Okay, this is the plasma steam workshop. I'm going to cover a little bit about my research into plasma steam technology. It basically came from the German library. It was the torpedo propulsion system. It's been a big mystery, and there's people out there who have similar technologies, you know, but they've made it out to be some sort of a mystery or some sort of a I don't know, what do you want to call it, a really exotic sort of technology, and it's not. It's really simple. So it's so simple that I decided just to let everybody know how simple it is, and let the guys who are supposedly experts on the subject, you know, I don't know, they can go do whatever they want to themselves. But this is basically what you're looking at here, right here. See that? They look pretty similar. My left-handed upside-down English will have to suffice, but that's basically what it is. It's a tube inside of a tube, and right here I cut out holes. So what happens is the water comes in here. I should have marked that. In fact, I will. It doesn't matter where the water comes in. It can come in anywhere, but this is just so happens one place you can put the water. And what the water does is it fills up, right? And then it hits the perforated points, so it comes out and it comes into the, and it's all the way around the tube. You're with me on this? So it's basically comes all the way around the tube in the inner tube, right? So the water is able to come inside of the inner tube. Now, there was some research done by a university on this. And here again, it came from the German library. And several people, I think, have played around with it. I think Tesla's had some people to demonstrate similar technologies. But whatever, this is what it is. It's simply a tube inside of a tube. And then what happens, what you get is a lot of people would think, you know, you get a single vortex action. You know, just sit there and do like this. But there are actually 2 or 3 vortexes going on inside. It's kind of wild to me, but
are they concentric?
They sort of, yeah, they move around. I mean, I just would think it would be just one. I thought it would be just one big vacuum tube sort of action. So what you do is you know, you send in the air. Now this could be a blower, you know, or a compressor or whatever. Obviously, a compressor would defeat your purpose because that's a lot of energy to put into a system. If I was building a megawatt, which I have, I have a huge one, much greater than that, 5-10 times bigger. Well, at least 10 times bigger. But this is this would require a blower. My other one would require a compressor. This is a blower system, whatever size blower, and that sends your air in. Okay, and here's where your ignition occurs. Of course, your spark and your spark plug would go here, and your fuel would go here, and your air would go here. Got it? Yeah, or you can use a glow plug.
But doesn't it just constantly
Once you ignite it, it's done. Yeah. You know, once you get the fire. So what happens is you get this flame going, all right? Of course, you got the water coming in, you know. So now you squeeze this off. You put a check valve there, and you kind of like let it build up, or you got a little bit coming out. You know, you got your valve there. So and you got your valve here. I mean, you know, you got your not a check valve. What is it? Yeah. Well, you know, keep it from back pressure. Get your back pressure coming back. Check valve. Okay. And all right. So now you got this steam. This water is actually in here now, swirling around in its vortices. Now, here's what I found. I went to a metal spinner. If you guys want to play with this, know that a metal spinner will save you a lot of money in terms of design, because they have the ability to take a tube and, you know, somewhat bring it into an egg shape. The egg shape is the ideal shape for what I call a direct fired steam. Man, I'm just lots of words. steam thing here. So, yeah.
That was in there, an egg-shaped chamber?
Yeah. Okay. So what you got here is, yeah, it's a ramjet. Exactly what it is. You hit it right on the head. But what we found was is the greater the ability to circle. Like, I built one that I had, you know, I special made just to test. Man, was it expensive to have it shaped. Whew. Don't recommend it because I machined it out. You know, and then I welded them together. You know, it took 2 halves. Anyway, you don't want to go there. I just wanted to see. Somebody told me it would work, and it did. Egg shapes are just a phenomenal structure. I mean, if you look at trees, I mean, they're egg shaped. If you look at eggs, they're egg shaped. You know, there's just a number of things in nature that's egg shaped. It's really cool. Leaves, egg shaped. You know, that's just, you know, you're driving down the highway and you go, wow, look at that, egg shape. Yeah.
So who would you accredit to
I would accredit to the way energy works. Energy, and I'll go back to the starship. Electrons move in an oval pattern. They don't move in a circular pattern. They move in an oval pattern. Sonny taught me that, and I've been able to verify it. Dr. Sonny Ward taught me that. And but I found it, you know, in nature, it's just that way. The oval is more consistent than with the round. I mean, even the Earth's not round. It's a little more oval than round.
Did we mention
Victor
Victor Strawberger by any chance?
Strawberger?
Strawberger.
Victor Strawberger. I'm gonna get to him.
Should that egg shape be pointy end down or pointy end up?
That's a good question. This way. So the pointy end's up. This one's down. What you want to try and do is capture that vortices as long as you can, because you got that steam coming down, blasting away at this vortices. I mean, and then you got it. Of course, you got it stopped up right here, so it's holding. Now, once you build that pressure and that steam, you know, is starting to create itself, and it usually happens very quickly. I mean, 30 seconds, 60 seconds, 90 seconds, depending on your fuel, depending on a few things, or your air, whatever. But you could pretty much get steam pretty darn quick. Now, once you've got the steam, then you can start letting, you know, start opening it out, and you find your medium. Now, as y'all,
Is that the valve on the other?
yeah, actually, this was I was playing around, and I put these two together. This was unfinished. This was my actual steam machine. So you're looking at the spark plug here. Oh, there's still a little water in that one. This is the spark plug. Of course, this was allowing me to control my air right here. Here's where I put the water in. Forgot how all this thing works. Been a while since I've run it. Well, your guess is as good as mine. Somehow that thing worked. Actually, it was a heck of steam. Actually, it was really efficient. I was really surprised. And the only way I could know this is because I ran it a long time on a small amount of propane, which on my big unit, that propane, man, it was gone in minutes, literally. So I found out that was a good steam producer, and it proved my concept. I was just after proof of concept. These aren't like prototypes ready for the marketplace. But although it would be a great for this like steam cleaning industry, like steam on demand, if you had a need for steam at your work where you had to steam off. Well, for example, there was friends of mine out in West Texas wanted me to steam clean some of their heavy equipment. It gets really messy, really nasty. But for them to bring a steam boiler or one of those steam cleaners, well, it just doesn't work like this one would work. This would be like super steam, concentrated, you know, and do the job. So it had applications there, and I built them basically. The design was for downhole. I was going to build a tandem series of these and run them downhole in an oil field. That was one of my basic. My motive to building the things were for the oil industry, just to test. And I played around with above ground, and we were looking to see how we can build them for below ground. At the same time, this is direct fired, so what you're going to get is the condensable gases mixed in with the non-condensable gases. So that's not the best kind of steam you want. There's a way to separate it, but you know, it's not simple. The other way to do it is to run a coil down the center of the tube, right? So you're heating your coils up, then you're getting clean steam. But it's basic. It's basic. It's very simple. So next time, sometimes somebody shows you, their new technology that's been around since 1936 that I'm aware of. This is what's happening, and there is a need for this. There is a demand. People paid me to build them. I lost interest in them, but at the same time, it taught me combustion technology. It taught me theory. It taught me a lot. It taught me just a number of different things that I wasn't aware of, and about BTUs and equivalencies and different things like that. And it opened my eyes, and it was my education. This basically was, where I went to school. Right here, I built 14 of these. No, 9, 10, 11, 12 of them. So on that note, I met with John Picard, who was working on another energy system. I said, man, this guy's got some really neat stuff. I said, I want to work with him. So I started helping him. And we became partners. And he was with Advanced Power Systems out of Kentucky. Now he's with me at Energy Trends, and we're building another energy system. So it's a couple of energy systems, actually. So we've gone beyond steam. We're no longer interested in steam, although it's not that there's something wrong with this, or there's nothing wrong with steam. Steam is a very important part of our existence, and it's in everything. So there's two ways to go about it. Again, direct fire just for steam applications. You can build it that way. If you want to go with clean steam, you got to run a coil through the center tube, and that's just, if you don't know what goes on there, then don't even try to build one to begin with. So point is, coils for clean steam, non-coils for just direct fired steam. Yeah, well, I thought that, but not necessarily. Actually, it kind of helps. You just got to be real creative. As long as you put the coils right up against the wall, and center it down, it'll maintain itself. It helped. I was surprised, but it still maintained a vortices because we could tell by the way the steam was coming out, spinning.
Is this a water feed tube coil?
Yeah. Yeah, like
And then when you boil your water and make the steam, what do you do with the residuals in the water, the dissolved salts?
Well, I didn't get that far. I just wanted to see if if I can make clean steam. But to be honest, I don't know. I didn't go that far. I just was going, wow, non-condensables. Condensables, that threw me for a loop. I just thought, well, I just made steam, I'm there. Well, now you're going to separate the non-condensables from the condensable gas. I don't know. So then I found out the struggle with all that. But anyway, it's just something, again, that it's just this is ideally just a direct-fired steam system that you can acquire steam on demand. It's something to know. It's just a good technology to have on hand. You may have a need for steam. Yes, Paul.
What kind of pressure and temperature are you achieving with the steam?
Well, that's the fun part. That's the fun part. I got some meltdowns, big time. Bored, nothing to do, had 9 of them, let's melt them down. So I got up to 2,000 degrees in a unit very similar to this. I just melted the living hell out of it. It was really cool. Because what happens is you got this right here.
Well, as soon as that kind of temperature, you got a lot of pressure.
Yeah, and I got disassociation too.
Oh, really?
Yeah, because why I could tell is that I could start turning back my fuel and the temperature kept going up. I start backing off on my fuel. I'm going, ooh, it's starting to turn red. And I'm backing off the fuel, and I'm watching my temperature go up. As soon as you get around 1,800 degrees, if you got the proper vortexes, you get some disassociation. See, I was all into that. That's really what got me motivated, because once I saw, and this is a visual, you're turning the fuel back, and your temperature's going up, and your machine is turning red. And you're going, I'm turning the fuel off, my temperature is going up, and the machine is turning red. What the hell's going on? Disassociation. So it was an interesting experiment. It cost me, quite a bit, but I learned from it. It melted up to right here, but I ended up having to tear it apart. This melted here because as it caves in, I mean, the heat just ripped this apart, and it melted all of this off completely. I mean, just, I mean, if you ever seen metal, I mean, first of all, you can't put it out, but it's just blob. It's just a big pile of glob, huh?
How thick the
This was, I think the first one I did was iron. Regular, I don't know, it was regular tubing, it must have been. It was pretty heavy, though. It was the heavy stuff. I can't remember, to be honest. I don't remember. It was thick, though. It wasn't a cheap, it was heavy-duty boiler pipe is what it was. No, it was heavy-duty boiler pipe. I mean, I melted boiler pipe. You know, 20... Yeah, and here again, you know, I'm reading 1,800 degrees, but, you know, that's up here. The temperature down here was much hotter. So I don't know what that was, because that shouldn't have melted at 1,800 degrees, you know.
You start dissociating steam, right? Those temperatures are known.
Well, yeah, they're known.
4,000 or something?
Well, no. 2020. Paul, you know what the dissociation is for steam?
I'm afraid I don't.
Okay, but it's somewhere around 2,000 degrees. No, dissociation occurs in a vortices like this at 2,000, 2,300 degrees. That's.
Well, when you have the counterflow of the gaseous fluid, you start to rip one against the other.
Well, you got more of a slant on that than I do. I don't know. I don't. All I know is this is what happened to me. I'm not a scientist in this respect. But I did get disassociation for that factor. Now, I may be wrong. I could be totally, completely off. The fact that I was turning down the fuel and the temperature was going up could have been another reason. God knows what. But all I know is, as I was turning the fuel, the temperatures just started taking off. I mean, literally just went, I'm going, oh, shoot. You know, that's when you back up. You go, oh, God. You just wait. Could have been that. There you go. It's just too, you know, here again, it was for me as an experiment. I shouldn't even gone to those temperatures. What I was building was a machine that was only needed to go 500, 600 degrees. That's all I needed to achieve. The fact that I went to 2,000 was just pure, you know, crazy, actually, because you had no business going there. But yeah, but you know, it's, you know, when I built 9 of these, different sizes, but basically the same style. And I, you know, I had nothing else to do with them. It was just learning. I would have never put these on the market. These were tests. These were something to play with. These were not to, I mean, I wasn't going into production. I was testing different ways of putting in fuel, because, and I'm going to tell you guys how to do that. That's the key. You want to get a super efficient, the efficiencies occur here in your ability to, how you can spray the fuel in. I used a number of methods, the technologies that are out there, where I can combine the air and the fuel together in a vortices, and then which, you know, changes this pattern. And then I was able to put the spark together, and it was just a good mist. I had a good mister, a good spray, like a fuel injector. I had a really super, well, I had a fuel nozzle from one of the, friend of mine works for the aerospace industry. And he got me one of those badass, you know, one of those really cool fuel nozzle jets that they use in the, is it an atomizer? But they use it on jets. So it's like I'm not even supposed to have it, right? But it was just an awesome, it made it, the efficiencies doubled. The efficiencies doubled. So I learned that to get the proper efficiencies, get the atomizing fuel, get that fuel atomized, and you get a fair amount of efficiencies out of it. Okay, on that note, I never got to test. I mean, all the guys wanted me to do, I mean, they were going to use their drip gas off the wells. Didn't need efficiencies. I was just going to work with the oil companies, a couple of my friends in the independent oil business. Just wanted some steam machines, and that was my motivation. I said, you guys care about efficiencies? Well, we don't want that. It's going to, you know, cost more than, you know, I mean, we want something semi-efficient. But the fuel was on demand. We had the drip gas was right there, and the natural gas was abundant. I'm in an oil field. So it's not like fuel cost them a lot of money. It's just sitting there. So for me, it didn't matter.
I have a real simple question.
Yeah.
When you first started up, where would your water level be inside the container? I mean, obviously it'd be below the intake hole, right?
Well, you just start filling it up, and that's, here again, this is another deal that you got to deal with. Control. I mean, you got to put a control on that. You got to feed it just right. You got to know what you're doing there. And you add so much water. If you overdo it, then what happens is you flood it. You got a dogleg overflow. Right. So, you know, you got to watch your water, you got to watch your air, and you got to watch your fuel. You got to watch all 3 of those. And you got to keep this, cut off at a proper ratio. In other words, you got to just kind of like, you got to feel. It's a touchy-feely thing. That's what I'm saying. It was a great education for me to learn this. It got me into the energy business, and this is like my childhood years right here, and I grew up to be quite the man. And I'll get to that here shortly. Okay.
How would that water feed in? I mean, just under the pressure building up around it?
Yeah.
Like a percolator?
Right. Yeah. Well, yeah. It's exactly what it is. It's once you back off, I mean, once you squeeze this off, I mean, that stuff just, that water. I mean, it's just basic. It's so basic. It's, what can I say? It speaks for itself.
The water is heating up and feeding in?
Well, actually, the water's kind of heating up, but really not. It's not heating up on the outside. It's actually keeping the jacket cool. That's what's able to keep that jacket from where the jacket's able to go to high temperatures. You follow me there? In other words, it's keeping the jacket cool. So I can, had I put some good 304 stainless down here instead of boiler pipe, I could have gone to those disassociating temperatures, and I did later. But it's still, what's the point? What was the point? Just because you're bored with the same old thing, you just fire it up, and make it red, and it definitely gets hot. You can get some high temperatures. The fuel, obviously, the fuel makes the difference. You get a hotter burn with, you wouldn't want to mess around with gasoline or I played around with alcohol because a friend of mine's an MIT rocket scientist, and he said, "Try alcohol, man. You're gonna get some wild stuff out of that." Yeah, straight alcohol. You get some hot temperatures and dangerous, explosive stuff. So don't use alcohol. You heard it here. Huh? Okay, so yeah, kerosene works great. Oil works great. I can burn oil. I mean, you can burn oil. You can use pretty much just about anything. And it's a direct-fired system. It's so basic, so simple. The Germans, those guys, they're smart, but they use common sense. And this is a common sense technology. And it came from those guys. They didn't. But the shape is the key. I mean, you want to get into efficiencies. You start looking at different ways to improve efficiencies. Shape is critical. If you can figure out a way to. It is a great pool heater. That's exactly what it would be. Great pool heater. You could just, if your mind can expand, you can think of all kinds of applications on it. I mean, I thought of several. I wrote them down. But here again, I'm away from that. I'm going to touch on this energy system we built. But John and I have gone beyond this.
I got to interrupt before you go on.
Yes, sir.
Just for a moment.
Yes, Paul.
Take the propane, couple that with a blazing turbine. Now you've got a market product to the natural gas industry. So then you say, hey, I've got a lightweight system that generates enough power to drive automobiles. You've got a market product right there, man. Couple that with blazing turbine, propane power, exhaust, water.
Right. That's right. Except for, I don't want to do that. I got 5 other projects I'm working on, and that's not even on my list anymore. But you're right. That's what we were going to do. In the bladeless turbine, I got the world's leading expert now. John Picard built the greatest Tesla turbine in existence. He was able to achieve Tesla's 38% efficiencies, and this is just, that's just now. If we do 2 or 3 more things, we change the bearings, we do this and we do that, we're up to 40, 42. And we're way ahead of the game in terms of turbine technology. He's able to take that thing to 15,000 RPMs and put temperatures unheard of through it, and we're talking dirty steam. I mean it's an awesome. The Tesla turbine is really what this video is going to be about, because John is here's a guy who's worked his 4 or 5 years with no pay. He's a spiritual brother, and I love him more than anybody that I work with, because he tries so hard to create things to help mankind. And here again, this is one of the inventions both he and I are working on, and we have a fuel processor he and I both developed together, and we're in this creative path right now that we're just coming up with all the ideas that we need, and for some reason they're coming through really, really clear, and we're getting right on building these things. And I'm going to touch on some of those tonight. But John is the guy that's responsible for the Tesla turbine. I'm ready. Okay, we're going to, is that it for the question?
Yeah, let's save our questions and answers. We've got a lot of material to cover here tonight, don't we?
Yeah, well,
So let's let
however
them
long you
cover
guys want to
material,
stay up.
And then we'll save the questions and answers.
Cool.
afterwards.
Okay. Ready when you are.
And then it'd be cool if you guys went onto the mics like we did on stage.
Yeah. Anyway. KISS, you know? That's all this is. Just keep it simple. Yeah. However you guys want to do it. But this whole thing is about this bladeless turbine, and I'll leave this here for you guys to look at after the presentation, but that's it right there. That's what achieved the Tesla's efficiencies, and we can go beyond it.
Greetings. You're currently looking at the
Okay, you gotta turn off
August
these lights
issue
here.
of Teba News,
Okay.
1998, issue number 14. It features a Tesla-type turbine built by Advanced Power Systems, in particular, a gentleman by the name of John Pickard. It contains a 12-inch diameter runner and is a part of a complete test stand. This video, while amateur in nature, is designed to give you an idea of how this unit works and what's involved with its operation. You can get this issue of Teba News by joining Teba. It is the current issue. And with your membership, you will also receive a 90-plus page membership manual. You can find us on the web by doing a search for Tesla Engine.
You got to get his plug in.
Okay, here we are at the shop of Sonny Intricate in downtown Louisville, Kentucky, and I'm here with Mr. John Pickard, and he has had a lot of experience building Tesla turbines. You may be familiar with John. He built the 11-inch turbine that was presented at the 1995 Tesla Symposium. He is actually the first person to take the Teba, Tesla Engine Builder Association plans and make a real-world working turbine after we had published the drawings. And he presented that turbine at the 1995 Tesla Symposium. And now he's stepped up to another project. Actually, he's had a series of projects in between, but this is his latest and greatest, which is a 12-inch turbine, which is running on steam, which is a direct combustion system whereby the combustion gases are making steam and then driving the turbine. As well, the combustion air is also driving the turbine in a low-pressure dual system, which John's going to explain to us how it works. So take it, John.
Okay, Jeff, the equipment that you see behind you right here is, the corporation that's behind it is called Advanced Power Systems of Louisville, Kentucky. I'm the Vice President of Advanced Power. Mr. Bob Stanley is the president of the company. We undertook a research and development project to see if we could develop a blower-driven, low-pressure combustion system that would also provide heat to a higher pressure steam boiler. And the results of our efforts are right here. If you use an air compressor to feed your combustion system, you're going to have to pay a lot more price and efficiency for the higher pressure air for the prime mover to drive the compressor. Like I say, this is work in progress, and at the current time, we have exhausted all of our funds, and so the equipment that you see behind me, the research and the turbine and the boiler are currently for sale. And so if anyone's seen the video would like to make us an offer, then please contact Advanced Power Systems here in Louisville, Kentucky, and we'll talk and negotiate on the price. But I'll be happy to, Jeff, if you'll go over here with me now, and I'll point out the various components and explain the theory of operation. And then after we do that, we'll crank the system up and show the speed. But for the first time, we have together an electric generator, which is surplus off of a B-52 bomber. It is a 60,000 watt, 80 horsepower generator, and it's being direct shaft driven by the turbine. And the turbine is being powered by steam from the boiler and the combustion is being provided by the air from an electric-driven rotary low blower, and we're using propane, and we've been able to have propane bottle that's sitting on an electronic scale, so we've been able to determine efficiencies. The efficiency numbers are not that high at this time because the size of the equipment needs to be increased and better heat exchangers, and then our efficiencies will come up. But we do have a viable running system that is research and development that is in progress. So I'll go over that with you now, Jeff, and we'll walk through the various components.
Okay. That right there is the turbine. That's the generator.
Jeff, what we have here is a roots rotary low blower back behind the door. You can't see it right now, but it's connected to this 2-inch line that brings the air in. Right here we have our LP gas bottle sitting on the electronic scale, and progressing on down the line, we have a valve right here that in the early parts of the development we're bypassing air in order to be able to start the burner, but we now have got all the bugs worked out before it starts instantly without any problem. This is a pressure gauge that tells us what our pneumatic pressure is right here. The air comes in and enters into a diffuser section that slows the velocity and allows it to build pressure. Behind our stainless steel flanges here, our bolts, we'll have an internal burner, LP gas burner manifold. This right here is a high voltage ignition box, and there's your spark plug wire. This is our gas valve, our gas pressure, and our main on and off gas valve control right here. The combustion ignition source is right in here. This section of the burner is lined with a ceramic refractory lining. As you come along into the main burner section, we have an 8-inch diameter duct tube burner that has 2 external pressurized jackets on it to preheat the water. The water is pressurized by our feed water pump at about 180 psi. The water source is in this tank, which serves several purposes. The first purpose, it's a pedestal base for the burner to set on. It serves as a water reservoir. It serves as a heat exchanger, and it serves as a muffler. And so here are 4 exhaust pipes that you'll see in operation after we start the unit up. The combustion gases that are generated pass through this cone right here into this 1.5-inch line that feeds a center section of the turbine rotor. In order to not have excessive back pressure, we have wider spaces in the Tesla turbine disc in this 1.5-inch center section of the rotor. The rotor is 4 inches wide. The outer 1 inches of the rotor are high pressure turbine rotor discs. The outer discs are 1/4 inch thick on the end disc, and then 1.5 inches in the center has wider spaces and wider discs. And that allows us to run on this pressure gauge in operation just 8 pounds of air pressure. But we do have expanded high cubic feet per minute high velocity gas going into the low pressure section of the turbine. Our temperature gauge is right here, and we have ran the gas temperature after it loses some of its temperature and gets it up to the steam coils. We have ran this as high as 1,200 degrees. But usually we can get a very successful run of anywhere from 750 to 800 degrees exhaust gas temperature entering the turbine inlet right here. This is our steam control. Initially, we're here at the Intricate Machine Shop, and my friend Sonny and I operate the equipment together. And Sonny has developed a very good operation technique concerning the boiler. We'll turn on our feed water pump with the master switch here, open up the valve, and flow enough water to expel all the air from the boiler. And then after the air has been expelled, we'll go ahead and light the burner, and within 2 minutes' time, we can produce dry, invisible superheat steam at around 300 degrees or so. We have had the steam with running the burner much harder. We have had 600 degree steam coming out here before, but the steam the quality is so good it's totally invisible. But we'll be putting it into the turbine just before it goes invisible. This nozzle right here is a steam diverging flow nozzle. It is a simulator nozzle to simulate the area and the flow of the diverging nozzle that's right here in the top of the turbine. The steam nozzles right here, we have the central line coming in, controlled with this valve, and the steam goes into this hollowed out block, and then it goes into two diverging steam nozzles into the high pressure sections of the turbine rotor. The turbine itself has a 4-inch wide rotor in it. The rotor and the shaft of this turbine weighs 100 pounds. With the 25-pound armature in the B52 generator, we have approximately 125 pounds of rotating mass. Once we get this thing started, we'll show you we have a tachometer right here that reflects off of a piece of white reflective tape, and we have a digital readout over here on the generator fuel control unit board. And we'll show you, we'll be bringing the generator and the turbine up to about 11,000 RPM. We have here an air line coming into a pressure regulator and a couple of copper lines going over. We use this air to cool the bearings because we're putting in sometimes 1,000 degree combustion temperature along with 350 to 400 degree steam temperatures. And so we blow the external heat off the bearing assembly that comes out of holes down here. The bearings that are in this turbine, there's a bearing in here and a bearing in here on each side. They are very high quality class 7 angular contact high-speed bearings. Let me give you an idea of how free the shaft turns. It turns pretty free considering you've got 125 pounds of rotating mass there. The pedestal base has a piece of 1-inch thick carbon steel that has been overlaid with the stainless steel to prevent corrosion. The B2 generator is mounted to this mounting plate right here, which is carbon steel that has been electroless nickel plated, and the turbine has also been nickel plated for corrosion prevention. These support struts right here are exactly the same length, and that provides us with proper alignment on our coupling. And so it's a system that seems to work real good. Our power cables coming off the B2 generator right here goes over here to our electrical load bank. The load bank consists of a main switch panel with a voltmeter and an amp meter, and then the power comes out of there into 4 distribution switches. So we can bring the electrical array on 25% at a time. The array has 96 750 watt ceramic tungsten heating elements in it. And so we can do approximately almost 100 horsepower of electrical resistance with our load bank and array. When we're running, then we take our volts times amps times 3 times each other and divide with 746, and that gives us our horsepower. And then we take our horsepower in minus the horsepower based on amps on both the electric motors, the blower, and the water pump. And then we take our fuel consumed in pounds, convert it to BTUs to horsepower, and then we're able to determine our efficiencies, which we have done. And what we have now is a running system. Efficiencies will be improved in the next generation. But this is work in progress, and we've pretty well got a good idea of what we've got to do. It's just a matter of getting the funding and the backing to continue. Concerning the exhaust jet, after the exhaust comes into the turbine here and into the steam, all of it spirals through the turbine rotor and comes out into the housing section right here. The exhaust then is transferred out these 3-inch lines back to the water tank for heat recovery to preheat the steam water. We have, off the pressure discharge of the feed water pump, a line on each side that goes to a cone-shaped spray nozzle that's in the center of each of these exhausts, and that water sprays down into the tank. Even though we're putting out, having 1,800 to 2,000 degree combustion temperatures, the temperature coming out our 4 exhaust stacks only runs at 170 degrees. So the system, from a thermal efficiency, as the heat in as the total heat out, is very, very good. The efficiency of making mechanical power is mainly going to be at the expense of the boiler, and this boiler is really too small to be giving us all the power we need. If the boiler was 4 or 5 times bigger, then we would definitely be up in a very, very competitive efficiency range. Okay.
Okay, you guys get the idea? You want to see any more? I'll go over. Well, he's got 10, he's climbing up around 10,000 RPM. Huh? It's the whole system. The boiler and the blower. And then that Tesla turbine node is pretty loud itself. Okay, you can cut her off. Okay, anyway, that's John. It's there's a saying my grandpa told me when he sees me working all this stuff, sees me spending all my money on this technology business, and he was reminded of a quote somebody told him one time. It said due to lack of funding, the lights have been turned off at the end of the tunnel. So that's basically what's happened to Steve. He basically had people he got involved with. Kind of just left him out there. He was the brains behind the project, and I got with him when he was just about finished, and I started working with him, and I said, look, Steve, you and I work together. So we're building a couple of energy systems, and we've joined forces under a company called Energy Trends, because he's a phenomenal guy and a genius designer. Basically, what you saw there is not much different than this, although he went pretty elaborate. But that's what he felt like the system was better instead of this, which is the way I had it. You know, that's where this brace is up here, so it could sit in my holder. But his is like this.
So how do we get that preparation and the flow of the water into the container?
Okay, run that by me again.
Well, with yours, you've got your holes
Yeah,
separated around the edge of it comes up.
right,
It's like this.
right.
So with this one inside, how does it get a fit?
You know, he told me that, and he's got these spray nozzles that's actually spraying the water in there. He went a little more elaborate in his, you know, his device, but not, you know, here again, it's basically pretty simple, but, you know, his was boiler tested, and that system is for sale, and that, because we've got another energy system that's, you know, we're just not going back to steam anymore. But he just got to pay off the people that he borrowed money to finish it. But whoever picked this project up, if you were, you know, I don't know if anybody's an investor here or into energy systems, but if you took over where John left, you'd have yourself about $1.5 million worth of research and an energy system that had approved a Tesla turbine's efficiency of 38%. He was able to measure and equate. I think the boiler, because of its size and its direct relationship with the turbine, the boiler turned out to be like 10% efficiency, but the turbine was 38, and then the generator, I forgot what the generator was, but none of them matched. Therefore, you had an off, you know, everything was off. But the turbine, we were able to, you know, scientifically, it's absolute. It was 38% efficient. That's the breakthrough. Anyway, that's John Picard's plug for the video. He knows I mentioned that. Okay, now on to some fun. Are you guys pretty well satisfied with that? I mean, I really want to move on, so since I'm running the show here, this part is over. Okay, on to the next thing. Okay, this is really this is going to be the fun stuff. That's steam technology, and that's nice. Okay, based on my research in the steam, you know, I've gone on to other areas of interest. And one of them, of course, being was an idea that I said, you know what? All these talk of Earth changes and the new millennium coming upon us. It was like I feel an urgency, and I don't know if it's just because the people around me are making me feel urgent, or it's the newspapers or the media, or just a feeling I got inside. I kind of tend to go toward the latter. You know, it's just something I feel like we need to be prepared. And in any case, like say, oh, well, you know, what are you getting all excited for? I'm saying, well, you know, if I had my choice, I would want to be able to be self-sustaining. That's the one thing that, you know, to me, that's freedom. And I lived in the Far East for a number of years, and those people, they didn't have a lot of money, but you know what? They were free. There was no policeman walking around. There was no power grids. I mean, they lived in candles. They had candles in their huts, and their fish was right out their front door, so they had food, and the fruit dropped right on their heads. You know, so they had everything they needed right there. They were free. We're tied to the grid. We're subject to the price of fuel. I mean, you know, we're slaves to our environment. We have to. We depend on our food source. You know that if the trucking industry was shut down, our country would be out of food in a week. In other words, if the trucks stopped, for some reason the trucks stopped, and the trucks couldn't get through your city, you'd have enough food in the Skags, and that's if you didn't get killed trying to, you know, get to the food store, if it comes to that. But point is, we're just too damn independent. I mean, too damn dependent on our society for our needs. And so I began to think, and that it's pretty dangerous for me, but I said, well, you know what? I'm going to come up with a home that's self-sufficient and have all the technologies that that will be able to supply the house, like obviously refrigeration, is important. I think the Cosmic Cooler is fantastic for food storage. It has the ability to extend the life of fruits and vegetables for 3 to 5 times. Not only that, it has regenerative effects. It actually, adds power to the fruit and vegetables. It makes the fruits and vegetables more energetic, I should say. I don't know another term for it. So I was really excited with the experiments that Sonny shared with me, and we came pretty close, and he visited me 4 or 5 times at my house, stayed with me for weeks, and we were able to share a lot of things together. And I'm convinced, without question, that this is the home of the future. And also, it's in the article of one of Steve's magazine, Exotic Research, this month. So you'll be able to pick up. So I just kind of did some research once I began to learn about it. I compiled quite a bit of notes. So if you get that magazine, look up that article. Okay, so basically, the Starship was, to me, the home of the future. I mean, it's nothing more than a giant capacitor that sucks in cosmic rays. And this right here is what they call the Thomson effect. It's that vacuum that sucks in the energy. Once the energy is pulled in, then it's just bouncing around the room, and hopefully you're in there somewhere and captured. But this right here, to me, I'm not sold on the design. To me, that's pretty, I don't know. I mean, if I had a wife, I don't think she would dig the style of home that presents itself. So I said, I'm going to come up with something a little more hip, a little more 90s, So I'm going to extend it out here, and I'll probably do another one right here. So follow what I'm doing here. In other words, I'm going to use his design into a home structure. Come out, so you don't have to just build. You don't have to just have this necessarily. And I'm going to put a skylight because you need the photons. Apparently, Sonny says it'd be better if you had a light that goes through here. So that may be necessary. There's a guy who's come up with a technology because the electrical grids that are in our house that literally just cover throughout the whole home really cancel out our own electrical fields. I don't know if you guys know that. I mean, they really have a great effect. I mean, the lights, these wires. I mean, it's not just the lights, but they actually got wires that run. And if you looked at it under an X-ray machine, I mean, you'd see this incredible grid that we're surrounded by, this electrical grid. Not to mention the outside grids and the microwaves that are passing through, and the cellular phones. And my God, there's just so much going on out there and all around us. And that affects us, whether we like it or not, or whether we choose it or not. It's still there. So there's a technology. This is separate from, say, like if you were to connect yourself to a DC powered solar panel or whatever. This is if you still had to hook up to some kind of a power system. The technology exists, and I'm going to publish this whole concept very, very soon. So this is something I'm past my water energizer, and I'll get to that. This is my focus, and it's the home of the future. And what it basically deals with is the electrical field that does not affect the human body, and it's just a whole other way of doing it. A scientist apparently had come up with a way to do that. So I'm very interested, and I'm looking to apply that. Also, there's a magazine that's out, and there may be several magazines of this type. It's called Alternative Engineering. It's an Alternative Engineering catalog. It's in Northern California. If you don't have it, it's a $4 catalog. I didn't bring mine. Actually, I left it. I'm still looking for it. It might be in my car. I was wanting you to look it up. I mean, I want you to show you what it is. But it's a $4 catalog, but it has everything from refrigeration to heating and air conditioning, and you name it. I mean, the efficiencies are just incredible. So I was just going to fill the house up with the latest technology, including air conditioning, or refrigeration, or water heaters, or all the stuff that we're going to need. We don't have to live like cavemen. We don't have to go back in time to survive whatever it is that may come upon us. But just so we can be energy efficient, I think, is the key. Now, this system that I've devised, I knew I had to come up with a few. There's a couple of question marks like, okay, water. To me, water is going to be the most critical factor that we're going to have to deal with, or not have to deal with. Maybe nothing's to be concerned about. But let's just say we were just smarter people and we wanted to come up with a way to utilize our water much more efficiently, because the fact of the matter is we are running out of water. I'm more scared of running out of water than I am running out of oil. I used to be worried about oil. Now I'm not worried about oil. The microbes, and I talked about that earlier. But I don't think we have a microbe that produces water, and we talked about that too. So, you know, unless we can come up with a way, and they say they can extract water from the air, and that's all nice and fine, but right now our aquifers are disappearing. I don't know if you guys keep up with that, but I do. I follow it very closely, and scientists are very concerned about that. I mean, we're building golf courses in the flipping desert, you know what I'm saying? We're just like so far gone mentally as to where, you know, what's smart and what's not. We're doing what's cool and what's beneficial for whoever. For mankind, we're hurting ourselves because we're watering the desert and we're losing billions of gallons of water a year needlessly. So because the people in charge are not being responsible, we as individuals have to look to be responsible if you choose to. So there's a technology developed by a group called bioengineers. I don't know if you guys have ever heard bioengineers, but they're like the coolest people I know. They're like able to take toxic water and make it drinkable using nature. And it's just awesome. So I was looking into their technologies, and I've got my old file on those guys. Because I can see using the water from the septic system, cleaning it, then energizing it, which is this right here. And what I've done is I've duplicated nature with this right here. I have 280 vortexes in a 12-inch disc. 280 vortexes. So I basically created, well, my patent work's not all the way done on, or our patent, this is John's cards as well. So what we've got here is a disc. And right here we put a magnet. Like the Earth has a magnet core, right? Well, it does, just so you know. And water apparently, you know, travels through the Earth and then back out in the skin, and it passes through the rivers. And it has these, you know, it has what we call the Fibonacci series. It starts out like this, and then it gets a little bigger, and it gets a little bigger, and it gets a little bigger, and it gets a little bigger. And then it starts out small again, and it gets a little bigger anyway. It's a constant. It's like from here to here is x distance, and from here to here is y distance. Well, it's 1.16 difference. In nature, the Fibonacci series is like 1.16 difference. So we found that to be the case in river activity as well. So we've actually duplicated nature and created a series of rivers in a 12-inch disc. Pretty cool. The fact that we put a magnetic core right through here, the water is sucked up through that magnetic core, and then it's passed down through the rivers. You see what I'm saying? And then we spin it because the Earth's spinning. It's like the coolest thing on the planet, to be quite honest. And I'm fixing to make them, a bunch of them, and I'm going to make them where you can just have it right in your hand. It'll be no bigger than the size of this motor. There won't be 280 vortexes, but there'll be enough to make it work. The longer you spin it, the more action you're going to get. And what happens to the water is it becomes absorbable. It becomes real. Well, you ever drank water and it's like you got to gulp it? This water, you know, it disappears. It's like drinking wine or whiskey. You know, if y'all ever drank wine or whiskey, y'all know what I'm talking about. It just absorbs. Well, same thing. Water is it's energetic. It's got energy in it. So it just so you're actually getting 100%. What the water wants to do is do its job. I mean, the fact that water doesn't have energy in it, what happens to water is it actually takes energy from our bodies. It's the very root of all problem in our society. It is the basis of all disease. The fact that we're made up of water, and the fact that we drink and live on deadened water. I'm not going to say dead water, but deadened. We take the life out of water. The way we store it, the way we treat it. It's you know, it's just an what do you, I don't want to call it a conspiracy of ignorance, you know, but it is, you know. We refuse to change because I don't know, but with this device, and there'll be in industrial models as well as home models, commercial models, I guess you call them. The people can, you know, energize their own water. But this, coming back to this, so the septic systems, and then you run it through with the bioengineers system. I'll call it the bioengineer system, and I'm not going to draw that elaborate system, but they got it together, and it exists, and everyone can build this. You know, this is stuff you don't have to go out and go, well, I got to go spend $500 million to put this system together. No, you can just look around your your neighborhood, come up with this stuff. I mean, this is stuff that I'll be able to say, anybody can build this. Anybody can put this stuff together, except for you got to get my water energizer, and you'll probably figure out how to do that once you learn how it works. But what happens is this is the energizer. I will call that the energizer, because you got to energize that water after you're still dealing with. And I just hate to even put these two together. You're going to go, nah, because actually I separate this, and this goes out to the garden. Did you know, I don't know if you guys knew this, you know how Jerusalem got started? You know the Jewish people all went there after the war, it's like they're going to resettle Jerusalem. They're going to make Jerusalem, the new place, for them to be. And well, that's all nice and fine, but it's a flipping desert, It's not like this great, big, wonderful place, or it didn't used to be. It is now. You know how it got to be really nice and how it became a very agriculturally sound place? You know who saved their ass? A German scientist. You know how he did it? Because the Jewish people were struggling. More and more people were coming into Israel, and Israel was like, "Oh my God, how are we going to feed these people?" First of all, the Palestinians weren't going to help. I mean, none of their neighbors were real proud of them people being there, so they weren't getting any support or any help from anybody. So they were basically, they were not looking too good. In fact, they were in trouble. More and more people coming in, less and less food there was. So what they did was, they went to scientists and said, "Hey, can you help us?" They went to this one particular scientist who they were recommended to. German scientist, which is kind of ironic. It was right after the war. And German scientist said, "I can help you." He says, "Well, we'll pay you whatever you want." He says, "No charge. No charge." He said, "This is what you do. You pipe your sewage into the desert." He said, "You'll be able to grow." He said, "You can't grow, you're not talking about root vegetables. You can grow, fruit trees, everything but root vegetables, they could grow in that." So they basically started piping their sewage into the desert, and they created this, and then they tractored over it, and they created, next thing you know, they got these incredible forests, incredible lush green, incredible, environment that they created. They were smart. The German knew what he was doing. And it worked. And it worked nearly almost overnight. It was that powerful. That's smart. Here it goes back. That didn't take a whole lot of sense. That wasn't some guy with a calculator that had to figure out the equation to the universe. I mean, he just said, "Hey, pipe your shit into the desert." Just that simple. You didn't have to be a rocket scientist. It was that simple. So what do? Let's go back to that. It's the simplicity. Septic system. Pipe it over here. Clean your water out. Run it back through. Power generation. Well, there's a couple because we're working on this, and I hope to have it out certainly by before the year 2000. But that's one of our technologies that we've developed, and it's a radiant energy device using wind power. And it's basically a capacitor that's capturing wind power. And I don't know, who knows, maybe it'll work, maybe it won't. We think it will. We're pretty sure. Okay, the other thing is a solar lens, and this is what's really cool, and I'm getting to the fun part now, but it's too bad I can't erase this because this stuff doesn't come off. So I'm just going to have to figure out a little corner. Okay, so here we got a house. Okay, but what about propane? What about fuel? Well, good question. Well, this guy that I know, and he's as crazy as any scientist I've ever met. He's a major theorist, but he's also a practitioner in that he builds things. He actually got his electricity turned off, and got so mad that he started figuring out how he was going to make power for himself. This necessity is the mother of invention, they say. Well, what happened was he come up with a way. He went and got in looking at technologies from the patent library. He went to the patent office and said, "What do you got under energy? What can I do for energy? What do you got here? What do you got?" Well, he thought solar was pretty cool, but he come up with a liquid lens, a liquid solar collector lens. getting late, something like that. What happens is he's got this super-powered lens that it's actually the dimensions of a human eyeball. Exactly the same. It has the same kind of a looky, feely touch to it. It looks like an eye. It's really kind of cool, but it's liquid. And it's patented. And you too can own one. Not yet, but pretty soon. He's getting ready to start manufacturing. He says it's pretty scary because, this is something the government or anybody wouldn't want you to have, because this thing does so many different things, it's kind of scary. But what he did is he took that liquid lens and he made steam, superheated steam, and he was able to separate the hydrogen from the oxygen, which technology exists. It's not some crazy idea that people got to go, well, I couldn't do that. Well, it's pretty dang simple. In fact, they were doing it, 60 years ago, and, these weren't rocket scientists either. These are regular people like you and me that were able to figure out how to do it. The key was this lens. So then what he ends up doing is he separates the hydrogen. He separates the hydrogen from the oxygen, and puts it in a butane tank. They're accessible. They're all over the place, especially butane. They don't sell that anymore, so you can pick up those tanks pretty darn cheap. I guess the propane tank could work, but nonetheless, he's got a whole tank full of hydrogen. He's got more hydrogen in one day of collecting solar heat. That hydrogen lasts him 5 days in power. So what did he do? He went and built him a hydrogen-powered car, which is pretty darn easy, too, to build. He had this little motor in a big old car. And he's riding down the street 55 miles an hour, running on hydrogen. So there's ways to do it, and there's and Paul he left, but he told me, well, you can power batteries. Use hydrogen to power batteries. I said, no kidding. Yeah, hydrogen cell batteries, whatever. I don't know. Hydrogen fuel cell batteries, I guess. So, well, okay, well, whatever you want to do. The cool thing is this does exist. Now, maybe I'm just, far out there, and I probably am, but at the same time, this is simple. This is not something that's not reachable by any means, I don't feel. And the fact that that's kind of free, it's solar. At the same time, you're capturing power from the hydrogen, which is the purest source of energy. Really cool to me. Now, the really cool part is if I put this all together in a nice book that you guys could just flip through and go, well, here's exactly what I got to do. Well, I'm working on it. Stay tuned. It's going to happen, because this is what I've got to do. This is what I think God has given me. This, all right, here's your assignment. Ready, set, go. And I got to go. I got to get this done. The water energizer, to me, is critical because it not only works at the level of a home unit, home use, but it also will be working at the level, like at the industrial level, like for wastewater systems and city municipalities. Because what it does is it speeds up nature. I basically create, 30 or 40 rivers, whether it be this size or the size of this room, and then I spin that thing, and I create thousands of vortexes or hundreds of vortexes or a dozen vortexes, but it's certainly not one vortex, which is what most what they call water energizers, they got the single vortex. And they actually get some activity from a single vortex. Can you imagine how much 280 vortexes give me? Quite a bit. Molecular dissociation, separation maybe, which is very possible. NASA actually even confirmed and verified that for me. Said they were pissed off because they didn't think of it. So I knew I was happy that they felt that way. They said we're definitely onto something. So based on this, again, this is something that I am working on, so you'll be able to access this fairly soon. I'm through Steve Elswick. When it happens, you guys will know. And that's unfortunate. I don't have a website yet, but I am actually building one. They are putting one together, and I say this is going to be through Energy Trends. I'll be somewhat distant from it, but all the stuff that we build will go through it. We have a fuel processor, we have a water energizer, a water conditioner, and of course our liquid ring engine treatment. But that doesn't fall under Energy Trends. And we've got 3 other new technologies on the way that we're working on. So, and we got to finish our patents, and all that's being worked up, or I'd be more specific. But I think I've been quite specific enough. You guys are getting to see what I'm doing. And I think what this conference is all about, is to share and let everybody know, kind of get everybody up on the speed. Because you know what? Because if I fall out tomorrow, if I wreck my car on my way to San Diego, you know, this dies. Well, I hope it doesn't. I hope you guys can get a picture, because this is common sense. Now, the only thing that you couldn't access that's not available, well, I guess you could, but you know what? You can find. The technology exists for purification. You can recirculate. Hell, they do it in space. They do it in all kinds of systems around the country. Reuse their septic water. Well, we need to be able to do that, but at the same time, I figured out that the memory of that water needs to be reversed. So you either run it through an allotropic cell and wipe out the negative memory, and then you spin it, which puts the positive charge energy back into it, and then you're able to reuse it. We're doing this now. What do you think our lakes are full of? Septic water. It's like, oh, I can't go there, man. I don't do septic water. Yeah, well, you know, you do. You do septic water. We all do. I don't know if you live next to a lake, but I do, and that's what the hell, that's what's in my water. That's just awful. So, you know, they chemically treat it, and, you know, God knows that poor water, what it goes through. But we think we solved that. I hope we have. But we took Schauberger. That's Schauberger. This is Schauberger. And the really, really, really cool thing, and I don't know if you guys kept up with Schauberger, if you follow Schauberger, if you have any kind of an idea what happened to him. But he was brought over to this country, and all of his technologies were loaded up, you know, on a plane, and he was brought to Sherman, Texas. He brought first to Dallas, Texas, which was kind of ironic. At the same time, he ended up in Sherman, Texas, where all of his technologies were basically cut apart to be, because they, you know, our government, or so, I don't want to say our government, private investors were, you know, had bought the rights. Somehow he had signed over the rights to all of his stuff. So they basically cut open everything he had done right in front of him just to see what was going on. They basically destroyed all of his inventions is what he did. And at that moment, I mean, he was, you know, his mouth just dropped. But he watched his inventions destroyed right in front of his eyes in Sherman, Texas. He went home 6 weeks later, he was dead. Back to Austria. So, you know what was really cool is I couldn't get a machine shop to work on this thing anywhere near my hometown. I couldn't find anything. The only place I could find was Sherman, Texas. Swear to God. And you know what? I didn't even put the two together until several weeks ago. So you know what? Sherman, Texas. Hey, it was reborn, Sherman, Texas. We're building several other technologies at Schauberger. And we found the perfect machinist in Sherman, Texas, the guy we can work with, the guy I can trust. The perfect country machine shop that I can deal with the right kind of guys inside. Sherman, Texas. It sends chills down my back. I mean, you got to be there to know what I'm saying. But out of all the places in the world to have his stuff being reborn where it was destroyed, to have it being reborn lets me know Schauberger, you know, is alive and well somewhere, and got a good sense of humor. Because he's, you know, he got basically his hope was that mankind could benefit from what he observed in nature. He wasn't an engineer. He was a guy who just observed nature and documented it. And this is what he would have wished to have built, that people could have the ability to energize their water. Because that is the key to life. Because we are water people. You know, that's just that simple. It's why our bodies don't run as efficiently as they should. That's why we're 12-cylinder Jaguars running on four-cylinder Chevette engines, you know. We're not running at our potential. We have the potential to be that 12-cylinder Jag, but we're putting around like Chevettes. Being straight up. So what would it be like to be a Jag again? I can't wait. I think the key's in water. I think the key's in water and mineral uptake, the proper mineral uptake, good rich minerals. That's the energy drive, and that's what Sonny Ward has done. Is he's captured that energy in his LP10. Electrons. Well, this is it. This is electron, and that you create that vortex. What are you doing? You're sucking in that ether. Somebody calls it ether. I call it energy. I mean, anytime you cause a vacuum, you suck in energy around it. I mean, we live in a sea of energy. Nature does that. Nature does that. And when you're running through, you know, when you're running down the nature streams, the vortex is occurring there. It's 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 occurring there. Always drink water at the bends of the river. Never drink water here. Always drink it there, where the vortex is occurring, where that thing's spinning. You know, on top of that magnetic field, which is at the core of our unit. It's so cool. It really is. It really, really is. This is like This is a child. I take it with me everywhere. It's in my car all the time. I won't even let it outside when I go home, because I've been on the road for several weeks. I keep it with me. Go ahead.
Can we take it apart and have a look-see?
No, never. Not in the history of my life. But you will get to take your own apart very soon.
What's in there?
Huh?
What's in there?
I basically kind of ran it down for you. I mean, that's basically what you're dealing with. Rivers. The only reason why you couldn't drink the water is because I'm having them plated. My rivers are going to be gold and silver plated. These plates here, well, you can't see them right here. These plates right here, the top plate's going to be gold, the bottom plate's going to be silver. Say again? It's aluminum, so it's not that, but it is neat. And the fact that I can put CO2 in there, and I lock it in, it just won't come out. You know, well, CO2 carbonation, right?
How many plates do you have in there?
Huh?
How many plates are there?
2.
Are the counters, rotating counters?
It's brother and sister just stuck together. Anyway, I run CO2 through there like I would make carbonated water, and I can't get that carbonated water out. It's locked in. That means it works the same for any gas, oxygen or whatever. It's infused in there. So I can put a little mineral pack in there. You know, you can put a little, I'm going to build a unit, or we're going to build a unit. That's what I said, that John guy, I give him all the credit here. He's going to build a unit that's going to be no bigger than a water pitcher. And our little energy drive will be on top. And these are our plates and our magnet here. So the water's going to be uptake. Well, you put some minerals in there, right? We'll put a little mineral pack. This cap pops off. You fill your water bucket, your water thing up. You drop your mineral pack in there, and then you spin it, and then you pour it out. There's your spout. You pour it out, and anything you drink will be energized. It'll change the chemistry so fast you won't believe it. You almost have to probably watch your uptake for a while. You probably have to only drink 6 ounces a day or something before you can work your way up, because it'll just be so much energy. And we have so little energy in our bodies in comparison to what we could have. The potential, our potential is so great. Well, we just can't wait I can't wait to find out. Because the key's in the water. It's always been in the water. The fountain of youth, water. It wasn't some special liquid or special river. We got a question. Go ahead.
I was wondering, what do you think about
Go, you're good. Okay, well,
but anyway, I'll talk to you later.
go for it.
Do you see a correlation between the cosmic coolers and ozone accumulator,
Yeah, very similar. I mean, I think the only thing that's different is Sonny's, an argon box doesn't have this shape. Sonny's taken pyramid technology combined with the Ark of the Covenant dimensions and, his own experimentation with the different, a number of layers, which, and taped together. He's just gone way beyond the argon box and Reich's work. And, he's bringing us back old technology combined with new. Well, yes and no. I mean, I followed his work, but it's. Well, I don't know if it's gone or not. I mean, I think a lot of people still look at his work as a model, but I'm really, Sonny Ward, he may look like a crazy inventor, but he's not. He's as grounded as any individual you'll ever meet, and he's a practical guy. And what he's done is he's observed something in his own cosmic cooler and in his own house, and I've observed him. If you knew him 3 or 4 years ago, you'll know what I'm talking about. He's gotten younger. There's no question. And this guy eats hamburgers. I mean, I finally got him to start taking some vitamins and a couple things, but this guy doesn't live on any. He's not a health guy. He doesn't. I'm like, well, I spend a fortune on my vitamins. I got my box of vitamins over there. It costs me $120. Keeps me going. He has no vitamins in his shelf. He just walks and lives on burgers and fries, potatoes, Idaho country. Very unhealthy diet. I won't say unhealthy. It's not my choice, but at the same time, his LP10, he violates all the rules and laws. I mean, his system. I mean, he stayed with me. I've seen him half naked, and the guy's got a body of a 20-year-old. He's just amazing. I think he sips on that LP10 a little more than probably, what he may tell you. But it made me want to go out and build one. It made me want to go out and build one for me. I don't want to be, working off a 1-ounce bottle. I'll be working off that 14, 20-ounce bottle and sitting around wondering what happens next. Because I think there's something to it. I think we capture energy, your food, your canned goods, your water, your everything can be stored in there and kept charged because it's a giant capacitor. It's just common sense. It's not, to me, it's not theory anymore. Sonny's gone beyond theory and built a machine that actually works and has proven it works. Red apples turn green, swear to God. You know what I'm saying? And I don't mean they turn green like funky green. They start reversing to where they once was. They go back. So that means, well, if an apple can go back, well, I know that we're cyclic in terms of our body chemistry. I'm not going to go back to be a 14-year-old. I mean, I can't see myself doing that. But what I can see myself doing is halting where I'm at, maybe improving some things, and staying at this particular cycle. Because when you go to the next cycle, and you go to the next cycle, and you have so many cycles, and you expire. So I believe that we can slow down or permanently stop our aging process with the ability to capture this energy in the foods and stuff that are stored in here. So I'm coming up with the plans on this house. Actually, I got my building designer working on the plans, and he should have been finished probably because I've been on the road all last month. I haven't been able to get with him, but he is working on it because I told him I don't want this design. I mean, I'm sold on its ability, but I'm not sold on its style. I like a cool house, so I'm working on a really cool house that, we can have a little more going on, than that structure. But Stunny's, he's made his house really neat, and maybe that's all you want. I'm saying both designs will exist. A home that, could be on a city block if you wanted it to be, or a home that you can build out in the desert or in the mountains or wherever. It really doesn't matter. But this stuff here, the technology exists, I was able to research it, and I'm no rocket scientist, I'm just a guy that, well, let's look here. I'll ask a question, or who knows, who might know, but they do know. I found bioengineers that can turn your water system into drinkable, potable water. I said, well, it's not energized, because now I've learned energized water is critical. At the same time, this guy who built this lens, because he wanted he got his electricity turned off, and he was able to separate and make hydrogen, store hydrogen. He could make enough hydrogen in one day to power his home and take care of his needs and fuel his car for 5 days. I thought that was so cool. Of course, that guy's, not long for this world. He lets people know what he's doing. And he keeps to himself, because if he promoted that, I'm sure they would have stopped him by now. But he's kind of crazy, and people probably just didn't, believe what he was doing, but he was doing it, and he is doing it. So the technology exists. We don't have to wait. We don't have to wonder when it's coming. It's whenever you want it to, whenever we want to get started. I'm working on it. What are you guys doing? I don't know. What are you guys doing? I mean, it's up to you, to start beginning to take a look at what's available now, not what's coming. This is available now. The Starship plans, I say they're available now. Actually, they'll be available within the next 30 days. The energy system, this stuff right here I'm working on, I'm going to be dealing with a guy by the name of Dave Katz. Get his catalog, $4. Make the investment. It's really cool if you're into even doing this kind of thing. Or sell it to somebody else and you watch them build it. Alternative Engineering Catalog. They have a website, but it's in Northern California, and I can't think of the city. I had the catalog.
What was the guy's name?
Dave Katz is the president of the company. And here's another thing you guys may want to look at. And there's all these kind of things. This is, it's called the Handbook for Homemade Power. It's really cool, too. I've learned a lot from this thing. And I'll leave it up here if you guys want to look at it and, find out who the publisher is, because this is really cool. It's got a lot of stuff in it. This is where you take, if you got a river running through your place, or it's just all kinds of ideas. It's common sense. It's creative. It's what we used to be. Our creativity is just, falling out somewhere along the lines. But there's some really good ideas on inventing things for the home and a number of different just different ways of looking at it. So this book is, I just brought it along. It's something I peruse through on occasion. You know, I hope this has, you know, been informative for you guys, and maybe this is a pipe dream, but I don't think so. I'm going to create it myself. How it works out, I will only know in time. The only thing that's potentially dangerous here is hydrogen's a volatile fuel, and probably all of you are aware of that. And, you know, maybe it's a dangerous thing to pursue, but the guy that's building it says, look, all you got to do is have common sense and be smart. So it's probably not something I'm going to be able to say, this is included, you know, here's your hydrogen machine, you know. Sure. Okay.
So it's potentially leaks out, you know, gas burner manifold, the stuff available though, hydrogen, those are the metals, we got hydride, like titanium, hydride, but it's just cheaper than spending money on titanium, you could actually screw it with iron pellets, and, or you could, if you want to be a recycler kind of guy, you could empty out catalytic converters.
Okay. Well, could you store it for a short amount of time? Because this guy says he only makes enough to last him, and then he runs it out, and he makes enough because he can make it on demand.
Yeah, what you got to do is you got to rig it up, and you store it in the hydride. You know, you got all these pellets in a tank, and basically you have to pressurize it or heat it up or both. There's parameters that you find, and for doing exactly that, all the parameters for the different hydride, different metals are in a book called Forever Fuel. It's by Steve.
Okay, so anyway, the information exists. The concept, to me, is all I'm trying to get across. I mean, say none of this stuff has been, you know, is 100%, you know, without some problems that have to be overcome. Although I pretty much feel like this can be dealt with. The system's a working model. They've done this. They've solved this. The hydrogen, the fact that we can make hydrogen from this lens is a breakthrough, I think. The lens is the key, and the lens is, you know, it's just awesome. Okay.
I would use this micro, it looks like it's dead, not on.
Okay. You want to come talk to this one? Tess? Huh?
Testing?
Yeah, there you
testing.
go.
There you go. Some years ago, I had the occasion to work with an inventor, one Sam Leslie Leach. You know, in you get the toys in the popcorn box, you get these lenticular lenses, so you kind of twist them one way or the other. He's the guy that invented that. And he got into he's a photochemist. He got into disassociating water into hydrogen and oxygen. And he did it with greater than unity efficiency. I saw test data where he was 270%. But basically, he had a cell where he ran up to 1100 degrees, and he pumped light photons of the yellow gold light into the water molecule. It expanded, and he sequestered it with other reactants, and the oxygen was sequestered, and the hydrogen fell together, and it kicked out a 4.48 MeV photon, and then he recycled that energy. Well, the reaction died when the oxygen was sequestered, and then he changed the valves and voided the hydrogen, and then he dropped the pressure, and the oxygen came off, and he separated them. He had 5 nines pure gases. He put this in a car. This was in Motor Trend, written up, and he could go down the road. The car, he was a Plymouth, and at the time that Chrysler was in financial trouble, he got the guy, Bill Anderson, who was working on the vehicles. And but the problem with the hydrogen internal combustion engine is that it's so elusive, it gets away. He said it was never going to be something that you could send your wife down to the store with, and it required special O-rings in the head to
Corrosive?
well, to keep it there. And but he had chase cars and a lot of security and everything, but he could never get rid of the umbilical cords for running his, he called it the SLX process. But he had the car out on the road and at 70 miles an hour ran off and ran away from everything else because the fuel was so good. But so I just throw that out.
Okay.
But why don't you talk a minute about that lens arrangement? Is that something that captures solar energy and just associates it?
Yeah.
Maybe you want to talk a little
Well,
bit about that.
I can only give you, here again, this is a guy that, you know, he's patented it, so I haven't, I mean, it's public. It can be accessed. And here again, I'm going to put all this together in a book in short order. I mean, I've already contracted the people to write it for me, and I'm already going over all my notes with the Starship, and I'm basically turning over my library of research about this whole concept to a group of guys, university students, and say, hey, here, put this together for me. And I've just had my, I've had my second meeting with them, and they're excited. My God, they're like, this is like to them, it's the greatest opportunity they've ever seen, just to put this thing together. It will include a lot of the things that are in the alternative engineering catalog, which is a really great, again, a great catalog. So the lens right now, to me, that's like on the side separate, and I will keep you guys informed. I mean, I was thinking of my web page. I just have to you keep up with Steve. It's the only thing I can tell you is that I'll be working through Steve. I'll put the stuff out through his magazine. And that's another thing. I don't know how much you guys are in support of his magazine, or if you're a subscriber, but I've never seen a guy that really, I mean, I don't agree with all the things that are his methods, and some of the people that he puts in his magazines, I don't necessarily agree with all the people that write articles either, and maybe the people don't agree with me, but I do agree with Steve and believe that his integrity is there, and he really wants to get this information to everybody, and we need to support that. So if you're not a subscriber to the Exotic Research, you need to become one. For another reason, there's good material in there, and two, it keeps me coming here. I mean, that's why I'm here. He's written articles. It's brought me here. So and other people, like me, will come. So we need to support guys like Steve, because there are not many left like him that are doing this kind of thing. So I'm about out of energy. I could probably answer a few more questions, and then I'm gonna shut down. Yeah, we've done it. I've covered it. Well, we got 2 hours out of it. I hope this has made some sense. This is right now conceptual. I haven't worked out all the details, but I am going to. My life's committed to doing this because I think it's important, for real. And this right here, this device, I think it's going to be neat. I've got a generator that a NASA scientist has built. I mean, I just now got him to start doing his patent work on it, so we'll have a really smart generator in the future. We may have an over Unity system where he's figured out a way, and I don't believe this until I see it, but he may have a 1 horsepower that powers a 50 or 100 kW power unit. I don't know how the hell he's doing it, but he says he can. But he snickers and laughs. He says one day I'll share it with you, but I don't know if he ever will. But so maybe that kind of power will exist for us. I don't know. I mean, I've seen a number of technologies in my research years, and I haven't found anything that's ready. I think it's still R&D. I don't know how fast. I mean, my God, we got, if the year 2000 comes and and there is reason to hurry, then we're lagging. Technology should have already been here for us to start cruising, because, well, put it this way, how long did it take us to start getting beepers? The beepers were invented in the late 60s, and we're just now starting to wear them. It takes so long from point of invention to widespread application. So the fact that we haven't even invented it yet, it's pretty scary. We need to be starting to think about what we can do on our own, and accessing things like that there's technology in the alternative engineering. There's free water for free energy water pumps. I mean, if you've got a river of water, you can pump that water as far as you want to pump it. Free energy. just hook it up. Some kind of way, centrifugal force that just pumps water on its own. They've got it in the catalog. There's solar collectors for pumps, for well pumps that just put a solar collector, pump your water out of your well. I mean, there's all kinds of ways that you can figure out to overcome problems that exist now. We don't have to wait. We just have to look into it. Okay.
You mentioned that you had a couple of 3 other things that you were working on. Are any of them in order of what's going on?
Yeah. One of them is an electromagnetic motor using similar to Searle technology, the law of the squares or the sine wave theory, but that's another conference. And also a perpetual motion machine that we're working on that we think we may have some success with. And so, an air-water engine. Okay. Okay. You're welcome. Oh yeah. Good night. For real. It is? It is? Really? Well, help me. Well, help us.
Well,
Can we do it?
well, yeah, but see, you got public health laws and that sort of thing.
Can't we get it? Solve it with as long as we meet the standards, the codes?
Well, now, whatever your water machine might be possible, but the reason you put the water on the golf course is, that's how you get rid of it.
Right.
And right here in Phoenix, there's 120, 30 golf courses.
All right.
Now, that's what's happening.
Yeah.
And some of them have old irrigation